Welcome back, citizens. This is part 3 and we'll be looking at condensers and evaporators. So let's have a little look and review what we've covered so far. So hopefully that we have learnt that the work is done in the evaporator and the condenser. This is done by the changing of state of liquid to gas or gas to liquid, and the process utilises latent heat. A quick look at a couple of condensers and evaporators. These are primarily the heat exchangers, and they come in many forms. The simplest being the indoor unit or evaporator, and the condenser or outdoor unit. Now, the indoor unit and the outdoor unit are primarily the names given to them in air conditioning applications. Let's have a look at slightly bigger condensers. We have outdoor units or air-cooled units, and we have indoor units, or in this case liquid cooled units. In the case of the air cooled unit, we have the cool air going on to the coils and the warm air coming off, whereas on the liquid cooled we have the cooling medium, which is generally water but can be other substances. We have the cool water going on and the cool water coming off. And then we would have the hot refrigerant gas going in and the cold liquid refrigerant coming out. So a quick look at plate heat exchangers. Here have a couple of examples. We've got the stackable one where you can bolt the plates together and you can vary the amount of plates depending on what load you have. And we have a sealed brazed heat exchanger. Now, if you look at the diagram, you can see how they work. We have the cold liquid going in one side and coming out that side, and then the warm medium going in the other side, and they travel between the plates between each other and are very efficient. And look at evaporators. We have the air-cooled evaporator and a water-cooled evaporator, where the warm air goes onto the back of the coils and then the warm liquid goes into there, and the cool air hopefully comes off and the cool liquid comes out. This is where the unwanted heat has been absorbed. Now, if we look at shell and tube evaporators, on the left there you can see the tubes of an evaporator where the cool liquid comes through, and you can also see here a sectional diagram. Now, the warm fluid goes on one point and the cold liquid comes off the other point, whereas the liquid refrigerant goes on at one and the superheated, hopefully, refrigerant comes off. Now, there are generally two types of shell and tube evaporator, this instance being direct expansion, where the refrigerant goes in one end through the tubes and comes out the other end. The water, however, goes around the outside of the tubes, and because of baffles within inside the evaporator, the water gets diverted and therefore becomes more efficient. And just to reiterate, the refrigerant is going through the tubes and the water is outside the tubes. And here we have an example of the flooded evaporator, whereas the water inlet and the water outlet, the water goes through the tubes and the refrigerant goes around the outside of the tubes. Now, this is far more efficient because the refrigerant is in contact with a much greater surface area of the tube, so they tend to do a lot more cooling. However, if you get a freeze up on one of these, you're going to split the tubes because the water expands within the tube, and 9 times out of 10 you'll end up splitting the tubes. Here you have a typical finned heat exchanger where You have copper tubes where the refrigerant goes through the inside of the tubes, and because they're in close contact with the aluminium fins, and when the air is blown over through the fins, that takes the heat away. You can, in certain circumstances, especially in places where there's high corrosion, the fins would be copper instead of aluminium, because the copper doesn't corrode as badly as the aluminium, and these are known as copper to copper coils. Now, if we were to look inside a water-cooled condenser, we will see that we have the cooling water coming on and the cooler water coming off, and in this case it's going through the tubes. And then we have the hot gas going on and circulating around the tubes and subcooled liquid coming out. That is because the water going through the tubes is cooler than the Tsat of the hot gas going in. So therefore the hot gas condenses on the tubes, turns to liquid and sinks to the bottom. If we have a look what happens inside a condenser, as you can see at the top right there, the superheated hot gas goes in. This part of the coil is where the hot gas gradually turns back into a liquid, where the latent heat is rejected, and this part of the coil is where we're hopefully getting some subcooling on the coils, and that's where the sensible heat is rejected, and hopefully at the bottom of the coil we're getting subcooled liquid out. So I look at the evaporator. We have high pressure subcooled liquid going in. We have the orifice, which reduces the pressure, and because it's reducing the pressure, it's turning it into a two-phase mix. A two-phase mix is trying to turn back from a liquid to a gas, and to do that it needs heat, of which it extracts from the fins and the copper tubes of the evaporator, and hopefully by the time it gets to the end we're getting superheated gas out. That portion of the coil is where we're doing the superheat. In this area of the coil is where all the latent heat is absorbing, and that part there where the sensible heat is hopefully the superheated gas, so we're not passing any liquid back to the compressor. Well, hopefully that explains the processes that are going on inside the condensers and evaporators, and in the next lesson we're going to look at compressors. I'll see you soon.